Hey Valerie, so this is Miss Tracy. Let's look at this probability stuff in lesson 114. So here we have a spinner with 8 spaces. So we have 8 possible outcomes, right? It can land on any one of those 8 when we spin it. So that's what that means. You've got 8 possible outcomes, 8 possible places for it to land, 8 numbers for it to land on. Now we're going to spin it 3 times. Probability just means the chance of. So what's the chance it'll stop on 3, 5, and 1 in that order? So we look at each one of these as an individual event. So we write it like this. The probability that it will land on 3, then 5, then 1 in that order. Okay, so the probability that it will land on 3, this is 1 space out of 8 spaces. So 1 space out of 8 spaces. We multiply that times the next event that we want to happen. The next event we want is for it to land on 5. 5 is 1 out of the 8 spaces. Then we want it to land on 1. 1 is just 1 out of the 8 total spaces. This is our calculation to determine the chance that it will land on 3, 5, 1 in that order. So we just multiply these. 1 times 1 times 1 is 1. And I don't know. Here we go. I don't know what 8 cubed is because that's what this is. Excuse me. 8 times 8 times 8. So let's just do it on the calculator. 8 times 8 times 8 equals 512. So 1 out of 512 is the chance that it's going to land on a 3 and a 5 and a 1 in that order when you spin it 3 times. You see where we're going? That's how you do it. Each one of these is an independent event, and in order to string them together, we multiply. In order to have them in that specific order, you multiply them against each other. All right, let's look at the next one. All right, the next problem says the spinner is spun twice. So there's only one spinner that we've talked about, and it's that first spinner. So there's 8 spaces on that spinner, so that's what you have to remember. The spinner is spun twice. What is the probability that it will stop on either a 3 or a 5? So 3 or 5 the first time and a 2 the second time. So remember the spinner, we've got 8 spaces on our spinner, right? That was 1 through 8. We want it to land on a 3 or a 5 the first time. So that's 2 different spaces that it could land on the first time. So it's 2 out of the 8 spaces. And we want the second time we spin it to be a 2. Well, that's just 1 out of the 8 spaces. So we multiply that. 2 times 2, 1 is 2, and 8 times 8 is 64. We know we can reduce this. This is a fraction we can reduce, and pretty much every time you can, if you can reduce a fraction, you want to. So if I divide this by 2, I get 1, and if I divide this by 2, I get 32. I can't reduce that anymore. This would be your answer. Are you starting to understand what we're doing here? We're just talking about the top number, the numerator. That's going to be the desired outcome. That's going to be what you want to happen. And then this is the total possible outcomes. Or you could say options. Right? This is all the possible options that could happen. When you've got 8 spaces on a spinner, then your denominator is going to be all 8 spaces, because when you spin it, it can land on any single one of them. So you've got 8 choices for that spinner to land on, right? So total possible options, total possible choices, total possible outcomes. We use the word outcome. It just means option. It just means, the number of choices you have available. That's what it means. So what you want to happen, we want it to be in one of these two on the first try. So you have two that you are specific about. And then on the second try, you have one that you are specific about, that you want to have happen. So we're just counting, right? We're counting these things. The number doesn't matter. It is, it could be colors. You could have 8 different colors and you want it to land on red or green the first time and blue the second time. It would still be 2 things and 1 thing. That's what we're looking at, okay? Let's try another one. All right, in this problem, we've got an urn here. The first urn contains 6 blue marbles and 1 red marble. And then there's another urn, and it contains 9 blue marbles. So let's draw a quick one of those. All right, there's our second urn. So we've got 6 blue and 1 red in the first urn, and we've got 9 blue and 3 red in the second urn. We're going to take 1 marble. A marble is picked from each urn. What's the probability that both are red? So we want the probability, let me get the pen here, the probability that the first urn, that one is red, the first urn is red, and then that the second urn is red. That's what we're looking for. So if this is 1 and this is 2, there's 1 red marble out of 7 marbles. So in the first urn, you've got 1 out of 7 chance of it being red. In the second urn, there's 3 out of 12 marbles that are red. So you got a 3 out of 12 chance that you're going to get a red marble. So that's what you're looking at. You're looking at the chances that it will happen in that given situation. What's your opportunity that can actually exist, or that can actually happen? So there's 3 reds out of 12, so you have a 3 out of 12 opportunity to draw a red marble from the second urn. So this was the first urn chance because you had 1 red out of 7. Second urn chance, you've got 3 out of 12 because there's 3 red ones out of a total of 12 marbles. Okay, now we multiply. 1 times 3 is 3, and 7 times 12 is 84. Now I know that I can reduce this by 3, so that would equal 3 divided by 3 would be 1, and 84 divided by 3 would be 28. So this would be your answer because we reduced the fraction, okay? That's all we're doing. That is all that we're doing. We're multiplying and then we're reducing our fraction. And the fraction comes from the chance that could happen. The total possible things that could happen, and then the chance that we want, the one thing that we want to happen. Usually this number is a 1. Sometimes it's a 2. Sometimes it's just about what's the possible draws that give you what you want. All right, let's look at the next one. All right, so this one says if 1 card is drawn from each of 2 standard 52 card decks. So we've got 2 decks right here, and we're drawing 1 card from each of the 2 52 decks. So that right there is our probability, right? Our probability is going to be 1 out of 52, or 1 draw out of 52. Let me make sure before I move on. If 1 card is drawn from each of 2 52 card decks, what is the probability that 2 blackjacks will be drawn? There are 2 blackjacks in each, so I want a black jack and a blackjack. All right, so I want to draw 1. I'm going to draw one card, and I want it to be a blackjack from each deck. This is a deck, and this is a deck, right? So first deck, second deck. Now in the first deck, there's 2 blackjacks in each deck. So I'm drawing one card, but there's 2 possible jacks that I could draw. So 2 out of 52, that's how many options I have to get that first draw. We're going to multiply that. It's going to be exactly the same for the second deck because it's identical. So 2 out of 52. So when I multiply that, I get 4 over, let me do this. I'll do it this way first. So 52 times 52, that's 2,704, right? 2,704. But we need to reduce this. Now the thing that I see is that these are reducible on the front end. So I could say 1 out of 26 times 1 out of 26 to reduce it. So I don't have to try to figure that out up here. So that'd be 1 over whatever 26 times 26 is. Which would be 676. Now I could have just multiplied this straight across and then divided everything by 4, which would have been 1 and 2,704. $676. So either way you wanted to do it, if you wanted to reduce it before you multiplied or reduce it after you multiplied, you'd still get 1 over 676. But the probability is as much about thinking through the problem and understanding what you're doing as it is just math. You've got to see the problem. And it does not, this is like drawing a picture of what's going on. This is your picture. This is your probability, but it's also your picture of what's happening. So this picture of what's happening is important so that you can then illustrate it in numbers over here. Okay? So write down what it is that you want to happen in your probability parenthesis and then illustrate it with numbers to the right. If you don't do that, if you don't have this picture, and then, like I did with the urns, draw a picture there too. If you want to draw a picture to illustrate and see what's going on, just to make it more visual, do that as well. To your paper, you can put on it what you want on it, whatever helps you do the problem. Okay? But that's all you're doing. This is the number of opportunities that this would be a blackjack in that first deck. You got 2 out of 52. 2 blackjacks out of 52 cards. And our draw is 1 card from each. So we're not adding them together. We're saying I'm drawing 1 card from the first deck and 1 card from the second deck. Independent decks of each other. That's the picture of what's going on. Okay, you've got to understand the picture. Let's move on to the next one. All right, in this problem, we're going to talk about a fair coin. Now, the reason it says a fair coin is there are coins out there that are weighted to land a certain way each time. But this is a fair coin. So this coin is going to land with equal probability on both sides. So that's why it says that. So don't let that trip you up. It just means that it's any regular old quarter that you might pick out of your pocket. Okay? So we got a quarter, and we're going to toss it 5 times. What is the probability, and this is the picture of what we want, of getting heads, heads, tails, heads, heads, in that order? So first let's talk about how many options we have when we toss a coin. We have 2 sides, right? So if we want it to land on one side, it's going to land on one side because it doesn't typically land on the edge. But it's going to land on either heads or tails. Those are our 2 possible outcomes, our two sides that it would land on. So if we want to land on heads, that's 1 out of 2 possible outcomes. We want to do heads again, 1 out of 2 possible outcomes. Tails, 1 out of 2 possible outcomes. Heads again, 1 out of 2 possible outcomes. And heads again, 1 out of 2 possible outcomes. That's all there is to that. It's very straightforward. 1 times 1 times 1 times 1 times 1 is 1. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All right? So think about what it is that you are doing. It is an actual physical thing that you could actually take a quarter out of your pocket and toss it in the air and see that it's going to land on either heads or tails. It's going to be 1 out of those 2 every single time. But you have a 1 out of 32 chance, that's your probability, that it will land heads, heads, tails, heads, heads, in that order, in any 5 tosses that you make. So if you take that quarter out of your pocket and you toss it 5 times and you get it to land like this, then you've just hit that 1 out of 32 probability. That just means that if you toss it 32 times, one of those 32 times is going to be like this, or has the opportunity to be like this. This is just really telling you that it's like let me show you the option tree. All right. So this is our probability. When we toss it the first time, it's either going to land tails or it's going to land heads, right? We want it to land heads. So the next time you throw it, it's either going to land tails or it's going to land heads. Tails or heads. The second time we toss it, it's either going to land, we want it to be heads, it's either going to be tails or it's going to be heads. We want it to be tails this time, so the next time it's either tails or heads. And then we want it to be heads again, so it's either going to be tails or heads. All right, looking at this chart, I'm going to fill in all the others. Tails or heads. Tails or heads. Tails, heads. I'm running out of room. I'll go this way. Tails, heads, tails, heads. All right, and this one would be tails, heads. This one would be tails, heads, tails, heads, tails, heads. All right, that's all of them. 1, 2, 3, 4. Oh, hang on, I'm already lost. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Oh, I need to go some more. $28, $29, $30, $31, and we have to remember that original chance, $32. So this does not matter right here. We don't need those. because this was our original toss at the very beginning. Oops, that's not what I meant to do. I meant to do that right there. So that was our original toss. All right, and this is the one we went with. So this is the one that matters, right? That's what we were looking for. Heads, heads, tails, heads, heads. But all of these possible options were there. The first time we threw it, it could have landed tails. Second time we threw it, it could have landed tails. Right? So there's all these little things that got in the way. There's 32 of these possible options that could have happened, but they didn't. Because we got that one stream out of 32 that worked. Does that make any sense? Okay, probably not. All right, I'm going to erase this. We're going to clear this. We're going to go to the next problem. But that's how the math works. The math actually takes into account all the possibilities without you having to draw a complicated chart. That's the point. All right, and I'm sure I didn't do the chart exactly right, but that's close to what you would be looking at. Let me clear this. We'll move to the next problem. All right, so it looks like you got everything else right in that lesson. The thing to remember about probability that you really want to know is you've got to get a total possible outcomes. And that's going to go on the bottom. That's all your chances. This is your total chances right here. And then what you want to happen. That's what goes on top. This is the question. What do I want? And that's what goes in the top number. The other thing you have to remember is that every time you roll the dice or draw something out of the urn or flip a coin, that is an independent event. So it doesn't matter what happened before. If I rolled heads and then or flipped a coin and said heads, heads, this one does not depend on what this one is. When I flip the coin, it just is what it is. It doesn't matter if I flip that coin 5 times, it was heads all 5 times. The next time I flip it, it's either going to land heads or tails, regardless. Every time I roll a dice, if it's a regular 6-sided dice, every time I roll it, it's going to land on either 1 through 6. I have 6 possible outcomes. So if I wanted, let's just say I wanted to roll a dice. This is just an extra bonus problem for you to see the illustration. We know what a dice looks like, right? It's got the little 6 sides here and the dots. And I'm pretty sure this is not the right way that they're done, but you know what I'm talking about. You've got 6 sides. So we got 6 sides. That's all the possible outcomes that could happen when I roll that dice. But I want it. What I want that dice. I want to roll it 3 times. And I want to roll that dice. I want it to land on a 2. And then I want it to land on 4. And then I want it to land on 6. That's the picture of what I want. So there's 6 sides. 2, this side right here, it's only one of those 6 sides. 4, it's only one of those 6 sides. And the 6 is only one of those 6 sides. So the probability that it's going to land 2, 4, 6 is 1 out of 6 times 1 out of 6 times 1 out of 6. So that would be 1 over whatever 36 times 6 is. So 6 cubed, 216. So I have a 1 out of 216 probability that it's going to happen in the order that I want it to happen. So that means if I were to roll those dice in sets of 3 times, 216 times, there's a chance that one of those times will be 2, 4, 6. That's all we're doing. So think about the physical thing in the real world, what it looks like, what your opportunity is for it to land on what you want. That's what you're doing. Okay, what do I want out of the total possible outcomes? And then when you have a string of those outcomes that you want, you multiply them. That's all we're doing. I hope that helps. I hope you understand now kind of what's going on with probability. It can be a little confusing. It can be a little bit tricky, but you have to be very objective. Don't get your like people who, especially like gamblers who roll dice, they hit that 7 and they hit that 11 or whatever number it is, they're on a roll, right? They can't go wrong. Well, the probability says that you will go wrong eventually. You're going to roll the wrong thing, the thing that you don't want, because there is the opportunity to do so. All right. And they play that game. But that's what gambling is. It's probability and statistics. The chances that, this card will come up, or the chances that the dice will land on this, or the chances that the roulette wheel, the ball will land on the number you want it to land on. That's probability. That's statistics. That's gambling. So Miss Tracy taught you gambling. Did you tell your mom I said that? But that's what we're looking at. There's a real physical thing going on, right? It's kind of like bingo. What's the chance that I'm going to call your number next? Well, if there's so many spaces on the board, there's so many numbers, it's one out of the total number of numbers, right? So my point is, it's a real world application that you can actually use math for. And it's kind of interesting and fun when you think about the real world side of it. Because you can actually apply it. You can actually apply this to the real world. All right, I'm going to quit preaching. I'm going to let you go. And I hope you understand more about what we were doing. If you have any more questions, please feel free to ask. I would love to help if you're stuck. And I'll talk to you later. Bye, sweetie.